Somewhere in Bangalore, a Swiggy engineer is staring at a dashboard. Numbers are scrolling past 12,000 something, 45 milliseconds, 820 milliseconds, 99.99%. To you and me, that's noise. To this engineer, it's the entire health of the system at a glance. So, what do these numbers actually mean? And how does one glance tell you if everything's fine or about to fall over? Here's the trap. A single number with no vocabulary around it doesn't tell you anything. 820. Is that good? Bad? Milliseconds? Requests? You can't tell. The vocabulary is what turns a number into a diagnosis. That's what this episode gives you. You already met two of these numbers last episode, so this is just a reminder, not a reteach. QPS, how many requests the system handles every second. P50 and P99, how long a request takes for the typical user and for the unlucky 1 in 100. Today we go one level deeper on both and we add a third number that neither of them tells you. First correction, a lakh people open the app and the server is handling a lakh requests a second are not the same sentence. 100,000 people can have Swiggy open right now, but most of them are just staring at the menu, deciding between biryani and butter chicken. They're not hitting the server every second, they're idle, most of the time. Only the ones actually tapping, searching, ordering, refreshing, generate real requests. That gap between people online and requests per second is called think time. So 100,000 concurrent users might only produce 2,000 QPs. Confusing the two is how people wildly overestimate or underestimate what a server actually needs to handle. Second new idea. It's not enough to know your QPs. What matters is how close you are to the edge. If your system can handle 10,000 QPs and you're sitting at 2,000, you have headroom, plenty of room before anything breaks. At 7,500, you're getting close. Response times start creeping up even before you hit the ceiling. Cross the ceiling and it's not a graceful slowdown. Queues start forming and things that used to take milliseconds start taking seconds. Now the third number, the one from the cliffhanger. Engineers promise reliability using something called nines. 99% uptime, 99.9, 99.99, 99.999. Every extra 9 sounds like a rounding error. It is absolutely not one, and here's why. Let's translate percentages into something you can actually feel. Minutes and hours a year. 99% uptime sounds great until you realize it allows 3.65 days of downtime a year. That's a whole long weekend of the app is down, spread across the calendar. Add 99.9% and that shrinks to 8.76 hours a year. Better, but still an entire workday of outages. Add another 9 and you're down to 52 minutes a year. Total. One more 9 and you're at 5 minutes a year. 5 minutes across the entire year for every outage combined. Each 9 you add is roughly a 10 times reduction in allowed downtime. Here's why this isn't just a trivia stat. Because some systems literally cannot tolerate the outage a lower 9 allows. Every UPI payment in India, from paying an auto driver to a business settling lakhs, runs through this rail. NPCI, the body that runs UPI, mandates 99.99% uptime for banks on the network. Not 99%, that extra 2 nines is the difference between rare glitch and money stuck mid-transfer during peak hours at scale. 3.65 days of a payment rail being unreliable would be a national story. 52 minutes a year is survivable. That gap is exactly why the nines matter here. They're a design requirement, not a stat you round off. So why doesn't everyone just build for 5 nines? Because each extra 9 gets brutally more expensive. Going from 99 to 99.9 might mean better monitoring and a faster on-call process. Going from 99.99 to 5 nines can mean an entire second data center, standing by just for the days everything else fails at once. The reliability curve is steep at the top. Chasing the last 9 is often the most expensive engineering work a company ever does. One more piece of vocabulary, because you'll hear these three constantly: SLA, SLO, and SLI. SLA, Service Level Agreement. The promise made externally, often with the penalty attached if it's broken. SLO, Service Level Objective. The internal bar the engineering team actually aims for, usually stricter than the SLA, so there's a safety margin. SLI, Service Level Indicator. The real number being measured right now, that tells you whether you're meeting the SLO. The SLI is reality. The SLO is the internal goal. The SLA is what you promise the world. Let's go back to that dashboard from the start of the episode, except now you can actually read it. 12,000 QPs, that's the load, and you now know to check it against the ceiling for headroom. 45 milliseconds, typical. 820 for the unlucky 1%. That's the felt experience. 99.99%, that's the promise being kept or broken. 3 numbers. 5 seconds, the entire health of the system. Let's put it to work. Same 8 pm Swiggy rush from last episode, but now watch the numbers, not just the chaos. QPS climbs toward the ceiling, headroom is disappearing. P99 latency, which was already the unlucky number, spikes hard. Now even more people are having a bad time. And because this outage is dragging on, the month's uptime number is dropping in real time, eating into the whole year's downtime budget in one evening. An engineer watching this doesn't need to guess. The vocabulary tells them exactly what's happening and how bad it is instantly. Here's the trade-off this episode lands on. More nines isn't free and it isn't always worth it. An internal analytics dashboard breaking for 20 minutes a month is annoying, not a crisis. A payment system breaking for the same 20 minutes is a headline. The right number of nines depends entirely on what breaks if you don't have them. 3 numbers, 1 vocabulary. QPS. How much load the system is under right now. P50 and P99. How the request feels for the typical user and for the unlucky one. And nines. The promise being kept measured in minutes of downtime a year. But here's the thing. Knowing these numbers doesn't fix anything by itself. They just tell you that something's wrong. So what do you actually do when the numbers say you're out of room? Next episode, the load balancer, the waiter who decides which kitchen gets your order, so that no single cook ever gets buried.